Hello and welcome to a video presentation on misleading graphs. Here's what you'll learn. How to identify and analyze misleading graphs. First of all, what are misleading graphs? Well, any graph that distracts the reader from fully understanding what he or she is viewing can be considered misleading. Here are some examples. Graphs with no title. Graphs with no labels on the axes. Graphs with no key when a key is required. Graphs with a vertical axis that doesn't start at 0. Graphs with different sized graphing icons or bars. Graphs without equal intervals on any axis. And graphs with a broken or squished axis. Now let's take a look at some examples of these misleading graphs. Here's a graph comparing the popularity of the PS3 to the Xbox 360. And they're using the game units as icons in the graph. Looking at just those icons, it looks as though the PS3 is 3 times as popular as the Xbox 360. But this is misleading because the vertical axis doesn't start at 0. It starts at 44.5%. And in this survey, 49% of the people said they preferred the PS3. And 46% of the people said they preferred the Xbox 360. Now, to be sure, more people did say they liked the PS3 than the Xbox 360 in this survey, but that's only a difference of 3%, not 3 times as many people. So that's why a graph whose vertical axis doesn't start at 0 can be misleading. Let's take a look at another example. Here are the math scores from 2003 for 4 elementary schools. This is a misleading graph. Look at the vertical axis. It starts at 299, not at 0. Because of that, it makes it look as though the kids at Overachievers Elementary are 3 times as smart at math as the kids at Dullsville Elementary. Let's remake this graph properly. Here's the same graph using a correct scale. We start at 0 at the bottom. We use equal intervals all the way to the top, and when we fill in the bars for each school, we find there really isn't much difference in the math scores at all. Here's a misleading graph with different sized display icons. We're comparing the average ticket prices for 3 sporting events: hockey, baseball, and basketball. Now, while the icons may be fairly representing their associated sport and ticket prices, it's the size of the icons compared to each other that's misleading. Look at the top of the basketball. That may very well be representing $38 to get into a basketball game. And the top of the hockey puck and the baseball may very well be representing $18 to get into one of those sporting events. But look at the size of the hockey puck compared to the size of the baseball. It's probably about 2 times what you would expect if they were in direct proportion to each other. So if you were to just look at the icons, you might think it's twice as much to get into a hockey game as to get into a baseball game. Now here's that same graph using bars and unequal intervals on the y-axis. Take a look at the y-axis. It starts at 0, but the first interval is a group of 20. It goes from 0 to 20. All the other intervals are intervals of 5. This is misleading. Because we didn't use equal intervals, it looks like tickets to basketball games are 4 times as much as to get into a hockey or a baseball event. A better graph would use the same icons or bars for each sport and have equal intervals going up the vertical axis. Now we can do a fair comparison between ticket prices for the 3 sports. Here's another misleading graph with a broken or a squished y-axis. This is the women's long jump, and the distance is on the vertical axis and the 4-year increments are on the horizontal axis. Because we have a squished axis, the very first interval represents 6.9 meters when all the other intervals just represent 0.2 meters. Because of that, we're going to have a misleading graph. It looks like there was a huge difference in the women's long jump distances between 1984 and 1988. If we actually made this graph not squished with the 0 at the bottom, it would look like this. And yes, there is a difference between 1984 and 1988, but it's not as dramatic as the misleading graph made it look. Congratulations! You've now learned how to identify and analyze misleading graphs.